Alright, so we're going to be looking at projectile motion today. So projectile motion happens when objects are thrown or shot or pushed or kicked off of some sort of height. It can also happen when things are thrown or propelled upward and then come downward. Projectile motion always happens in a curved path. So basically, let's say that you have some height. Let's use white. You have some height, and then you have an object that is flying off of this height. So maybe it was pushed or kicked. So it's going to be coming out. So it's going to move horizontally, but it's also going to move down. So what you actually have is a curved path that looks something like this. And at each point, you actually have an x velocity and you have a y velocity. And you will see that along this path. So we have curved path, and we have two components on this path, an x component and a y component. So there are going to be two components in the x and the y direction. And then what you have to remember is that they are independent of each other. So the x velocity does not affect the y velocity. So if I had two objects and I drop them from the same height, let's say that I have 2 pennies, I drop them from the same height, except actually one I drop just straight down, and then the other one I throw with a horizontal velocity at the same height at the same time. So if I drop one versus if I throw one at the same height, they will actually land at the same time because x and y are independent of each other. So when you're looking at the x direction, so basically you have this object, it's been thrown horizontally, and you know that it will start to fall down as well as move to the right or to the left. So when you're looking at the horizontal motion, well, if you're up there at this height and you push it, once you push it, you're not applying a force anymore. Or once you shoot it out of a cannon or anything like that, you're not applying a force after it starts moving. So since there is no applied force here, there's no net force, so basically there is no acceleration. It's not going to slow down or speed up in the x direction. So in this direction, if the velocity starts at 5 meters per second in the x direction, it will be 5 meters per second at the end of the trip because there's no acceleration, and that includes slowing down or speeding up. So in the x direction, we're going to be using this equation. So in your x direction, you only have 3 variables. You have the velocity, you have the displacement or the distance, and you also have the time. So there's only 3 variables in the x direction. Okay, so for y, well, when you're looking at an object that is falling, since it is falling, it will have an acceleration due to gravity. So its acceleration will be 9.8 meters per second squared. So when we're looking at the math component here, we can just assign the acceleration due to gravity as a negative value and then decide if your displacement in the y direction if those are negative. So you're going to decide if displacement or velocities are negative. So if you're falling, your displacement is going to be negative, and also your velocity will be negative as well. So in the y direction, we're going to be using the kinematic equations for UAM. So these should be written down in your notes. Those 4 equations that look like this. Okay, so in the y direction, you will use these equations because there is acceleration and it's also a uniform accelerated motion. So basically, the acceleration stays the same throughout the fall. So for x, you're going to use the baby equation, velocity equals displacement over time. And then for y, you will use these 4 equations depending on whatever is given to you and what you're solving for. So whenever you are solving projectile problems, you're going to separate the components into x and y. So do you have a velocity in the x direction? Do you have a displacement in the x direction? Remember, x is always the horizontal motion, and then y will be the vertical. So separate everything out into x and y's. Time can be used on both sides. So time is the one variable that will be the same on the x direction and on the y direction. Everything else will more than likely be different. Okay, so let's go ahead and solve a problem. So a student sits on the roof of their house, which is 12 meters high. She can launch water balloons from a slingshot at 14 meters per second. If she fires a water balloon directly horizontally, how long will it be airborne and how far forward will it travel? So let's look at this problem right here. Okay, so first thing I like to do is I like to draw a diagram kind of showing what's going on. So we know we have a height of 12 meters, and we have a girl standing on this height, or roof, which is 12 meters from the ground. We know that she is firing water balloons from this height, and she's firing them with a velocity of 14 meters per second. And I know that that is a horizontal velocity because it's talking about firing water balloons directly horizontally, so that's my horizontal velocity. So what I'm actually going to have is the water balloon making a path that looks like this. So I would like to know how long will the balloon be airborne. So I want to know the time. And I also want to know how far forward will it travel. So what I'm looking for here is a distance. The distance from the beginning of the house to where the water balloon will land. So I'm looking for a distance in the x direction. So what I'm going to do is I'm going to say I have 2 components. I have x and y. I'm going to split all my information up into either an x column or a y column. X is the horizontal, so it's the horizontal motion, and y is the vertical. Okay, so let's see what I know about my components in the x direction. So I know I have a horizontal velocity of 14. I don't know time, it's asking for time. And I'm also looking for delta x. So I know in the x direction I can only use this equation. That's the only equation I can use for x. So I only have 3 variables. I have velocity, I have time, and I have displacement. I do not have enough information right now to solve for time or displacement because I only have my velocity. So let's go ahead and look at y. Well, I know in the y direction I have an acceleration, which is negative 9.8 meters per second squared. I also know that my height is 12 meters. So instead of saying delta x here, I'm going to say delta y. And I just mean that it's moving in the y direction. It's vertical. And that's 12 meters. And since this balloon fell 12 meters, I'm going to assign it a negative value. Okay, so I also know that my initial velocity here in the y direction is actually 0 because it doesn't start moving down until after it starts moving off the cliff. So its initial velocity is 0. I do not have a final velocity, nor do I have time. So this is the first step that you should always do when you have a projectile problem. Divide everything out into x components and then y components. Alright, so now I know I can't solve anything right here because I don't have enough information. But if I get time, I'll have enough information to get my displacement in my x direction. So let's go ahead and solve for time here. So again, with y, I'm going to use my kinematic equations. So hopefully you either wrote them down from the last slide or you have them in your notes. So what you want to do is you want to pick a kinematic equation that has only one unknown variable. So if you look on your kinematic equations, let's see, this one right here, delta x is equal to vi times delta t plus 1/2 at squared. This equation fits the bill. I have delta y. Remember, delta y and delta x are the same thing here. So I have that. I have my initial velocity. I'm looking for time. But I also have acceleration, so that's only one unknown variable here. So let's use this equation to solve. Alright, so now I'm just going to plug everything in the problem. So delta y is negative 12. Vi is 0 times delta t plus 1/2 times a, which is negative 9.8 times t squared. Alright, so now let's simplify. So first of all, this right here, 0 times delta t, this can be taken out because 0 times any number is going to give me 0. So it's negative 12 is equal to 1/2 times negative 9.8 times t squared. Okay, so I have negative 12. That's equal to 1/2 times negative 9.8 times t squared. Multiply these out first. So 1/2 times negative 9.8 gives me negative 4.9 t squared. Alright, so now I'm going to come over here and finish solving. Negative 12 is equal to negative 4.9 t squared. Well, I'm going to divide both sides by negative 4.9. So that's going to give me .448 here is equal to t squared. So do not forget to do the last step and take the square root. So the square root of this will give me 1.56 seconds. Alright, so now I have the time. The time is 1.56 seconds. Now, in the notes, I also said that time will be the same on the x and the y. So now I have time for x. I also know that for x, I will be using v is equal to delta x divided by delta t. That's the only equation I can use in the x direction. So I'm going to go ahead and plug it in. Velocity is 14. Delta x is unknown. And time is 1.56. So now to solve, I'm going to multiply both sides by 1.56. So delta x is equal to this times this, which gives me roughly 21.9 meters or 22 meters. So now I have my distance. So I know that the water balloon is going to go over 21.9 meters, and I know it's going to take 1.56 seconds to do that. All right, so a few tips when you're solving projectile problems. Start by dividing your components up. So you have x and you have y. The only variables you have in your x direction will be a velocity, delta x, and then also time. And your y direction, you could have delta y, you could have acceleration, which will always be negative 9.8 meters per second squared. You could have different variables here. Normally what you'll see though is that the initial velocity is going to be 0 in this case. VF and then delta t. So these are the 5 variables that you can have in your y direction. These are the only 3 variables you can have in your x direction. So I would start by writing this very thing down every single time, and then going through the problem and filling in what I have and what I'm looking for. Time will be the same for x and y. Acceleration is always going to be this. Velocity, VI, will normally be 0. So start off by doing this. List your variables. A is given to you all the time. Time will be the same for both x and y. So what will normally happen is you'll look at your components. You'll see that you have to solve for time in either the x direction or the y direction, and then go back and solve for another variable. That's normally what's going to happen. All right. The next couple of days we're going to be doing a lot of practice problems. You need to make sure that you understand how to do this and that you also practice, not just listen to me talk about how to solve the problems. You have to do this yourself. All right, and I'll see you in class next week.